First of all, the computation of limits is applying method 1, which is direct substitution method. For example, limit of function fx when x approaches a is equal to sa. This means that we will substitute the value of a into x. Next, we will move on to the limit of rational function. In this case, we will find the limit with two methods, which is factorization method, known as method 2, and multiplication of conjugates, known as method 3. We will use these two methods when we substitute the value of x with a and we get 0 over 0. In method 2, we can use long division or synthetic division to factorize the quadratic equation of the limit. Meanwhile, in method 3, we need to find an alternative way to find the limit. Firstly, we need to multiply the limit with the conjugate. Next, we can proceed to the multiplication, but don't expand the denominator. The other case is expand the side that contains third and its conjugate only. For the next part, we will go to one-sided limit. When the limit is from right to left only, the limit is not exist and hence it is called as one-sided limit. Meanwhile, when the limit is from both sides, the limit is exist and it is called as two-sided limit. To evaluate the limit, we will use method 4, which is separate the limit into two parts, plus and minus, and then we will simplify it.
Next part, test part system for limit. A limit exists if and only if both one-sided limit exists and equal. In this case, we will use method 5, which is the limit of function fx when x approaches a from left is equal to limit of function fx when x approaches from right. Then, we will go to infinite limits. Method 6 is used in infinite limit. Also, we can use infinite limit to find vertical asymptote. Method 6 is when 1 over 0 is equal to positive infinity or negative. Meanwhile, limit at infinity is related to infinite limits. We can use limit at the infinity to find horizontal asymptote. Don't be confused. In this case, we will use method 7, which is limit 1 over Sn is equal to 0, where n is greater than 0. Lastly, limit at infinity of rational function is used method 8 to find the limit. In method 8, if the limit is equal to infinity over infinity is undefined, then we will have to divide each term by x to the highest power of the denominator, known as option 1, or we can factorize the highest degree, known as option 2, to find the limit. As for me, I would prefer option 2 to find limit. How about you?
Next, in 8.2 asymptotes. A line x equal to a is the vertical asymptote of the graph if limit x approach a positive fx is equal to positive infinity. Step in finding the vertical asymptotes is, first, make sure that the function is in simplified form. Then, find the value of c that make the denominator 0. If x equal to a cause the denominator to be 0, then next check whether both limit x approach a positive fx and limit x approach a negative fx is approaching infinity. For horizontal asymptotes, the line y equal to b is a horizontal asymptote of fx if it's either limit x approach positive infinity, fx is equal to b, or limit x approach negative infinity equals to b.
Continuity is a function of y equal to fx that can be graphed throughout its domain with one continuous motion of the pen, that is, without lifting the pen, is an example of continuous function. A function y equal to fx is continuous at x equal to c if and only if it meets all three of the following conditions. First, fc is defined. Second, limit x approaching c fx exists. And third, limit x approaching c fx is equal to fc. Next, continuity at endpoint. A function y equal to fx is continuous at the right endpoint a of its domain if limit x approaching a from right fx is equal to fa. And a function y equal to fx is continuous at a left endpoint b of its domain if limit x approaching a from left fx equal to fb. function y equal to fx is continuous at a left at point B of its domain if limit x approaching f from left fx equal to fb.
Order food you love with Food Panda. Download the app and order now.